Hello friends, welcome to our channel, that is Hariharan Express channel. Today we will discuss regarding on shift micro operation. Okay, it is a transfer of information, that is in different ways, either go through left to right or right to left of data. Whenever it will transfer, then it is shift to left to right or right to left. So if we go through some definition of shift microoperations, we can define it is a serial transfer of information. Shift microoperations are serial transfer of information. And why it is a serial transfer of information? Because whenever go through any data or information, it contains the number of bits, and if shift its position from one place to another place or left to right, automatically the serial data or serial bit data transfer from one end to another end. That means it can be shift serially of bits from left to right or right to left. For that reason, we can tell as it is a serial transfer of information. And another thing, it transfers the information from left to right. You can see it transfers the information from left to right or right to left. Either or case, whenever this is required, we have to transfer from left to right or right to left. We can also consider. Or whenever you transfer from left to right or right to left, definitely some data will be lost. Okay, data will be lost. Why? Because if we go if we transfer data from left to right, some data shift its position, okay, from left to right, or some data is added to its position, okay, by which some data will be lost or some data will be gained. Okay, different ways as our requirement. For the reason, whenever you lose, how much data will be lost, that is important. Okay, or if you gain, how much data will be gained. So these two kind of things we will consider whenever we transfer any data, that is a bit of data from left to right or right to left. If the data transfers from left to right, it loses the data which is divided by 2, because whenever we go through any kind of a bit data, maybe 4 bit, 2 bit, 2 bits data, 4 bits data, 8 bits data, then each data means its position of data is defined through, that is 0, 1, 2, 3, 4, 5. Sorry, 0, that is next is 2 to the 0, first one. Second one is position of data, like 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, like this. It will continue. Okay, data will be considered in this manner. All of you know that, I think. Okay, that means suppose any data we have to evaluate, the data should be evaluated in this manner. For example, like we consider suppose data 0, 1, 1, 0, 1, 1. Okay, so what is the decimal data of this particular binary data? Okay, that means here you see, since its position is 2 to the 5, so but we consider 0 here. That means 0 into 2 to the power 5, and this position of data, this one plus 1 into 2 to the power 4, plus here similarly 1 into 2 to the power 3, plus here similarly 0 into 2 to the power 2, plus here is 1 into 2 to the power 1, plus 1 into 2 to the power 0. Okay, like this we can find out its corresponding decimal number. If data is defined in this way and its position is defined 2 to the power like this. So what is the total data or what is the decimal number of this? Here will be 0, very simple. Here 2 to the power 4 means 16. 2 to the power, because 1, it is 0 means total 0. If 1 into 2 to the power 4, that means 16. 2 to the power 3 means 8. Okay, here will be 0. Okay, here will be 0. Next, here will be 1. 1 into 2 to the 1 is 1. Plus 1 plus 2 to the 0 means 1. 1 plus 1 means 1. So, what is the total data? 16 plus 8. 24 plus 2 or 3 total. 24, 3, 27. That means 27 we defined in this manner. Okay. Means 27 is this is the decimal number. Okay, whenever convert to binary number is defined in this way. Okay, so how would we get this decimal to binary number? That is, I think all of you know that, divided by 2. Like 2 here is what 13. Okay, 13 is 1. Next 2 6, that is 1. When 2 3, here is 0. Okay, 2 again 1, here is 1 again 2. Okay, so this up to here. Okay, up to here we can find up to here. 2 1, not 1 actually, it is 1 maybe 1. Then what happens when 1, it will be also 1. So we can write 1 actually not there, but 2 1 means 1, but here is defined 2 1 1. So no problem, here up to here we can calculate 1 1 0 1 1, where whenever we go through this one, that is we can get, that's how much you see 1 1 0 1 1 1 1 0 1 1. In this way we can calculate, but think that it is the value of 27, doesn't matter. But whenever we go through this calculation, each position data is defined by 2 to the power 0. Okay, whenever you loss, then what happens? I told you, whenever loss, it is divided by 2 whenever it is shift from left to right, and whenever shift from right to left, it again multiply by 2. You see, if this is loss, that is left to right, that means 1 bit is gone out. That means it is loss. 2 data, the 2 to something divided by 2 to data divided by 2 data, it will be loss. If we shift to that left to right, right to left, then we add some data which is multiplied by 2. You see, whenever you go through this one, whenever right to left, you see 2 to the power some data is increasing. Okay, whenever go from left to right, 2 to the power something is down. You see 5 4 3 2 1, 2 to the power is down. That means it is a loss, slowly loss. And if you go from right to left, it will be multiplied by 2. So in this manner, the data will be, that is counted from left to right or right to left. Okay, now see these are the, but we have to remember these 4-5 points whenever we consider shift micro operation. Okay, but I will take some example, then we will confirm how it is shifted or shift operation we will use for shift micro operation. Next is we will see that what are the category of shift micro operation. Okay, normally basically we know that shift micro operation is that is shifted from left to right or right to left. Still some category of or types of shift micro operation are there. So what are those? We can tell as a first one is a logical shift micro operation. Second one is a arithmetic shift micro operation. Last one is a circular shift micro operation. These shift micro operation are very standard micro operation, shift micro operation, that is logical, arithmetic or arithmetic, as you like you can spell it, no problem. That is another is a circular shift micro operation. But question is another may be possible, but may be there, but it is very standard shift micro operation, and each micro operation having, you see, two part, because I told since it is a shift micro operation, we consider or we transfer data from left to right or right to left. So for that reason, each category of a shift micro operation we consider both left to right or right to left. So here you see, first one similarly logical shift left, okay, logical shift left, similarly logical shift right. Similarly we can consider arithmetic shift left and arithmetic shift right, circular shift left and circular shift right. Like this, a different category of shift micro operation, but its corresponding transfer of data either go through left to right or right to left. So each individual category having two category of shifting that is operation we will consider. Okay. Now we will start our example. Today we will discuss that is a logical shift operation. Okay. What are the example or how to define the logical shift micro operations? Okay. One example I will take it, then when I will explain, then we can find out how it is evaluated through logical shift micro operations. One example I will take. Okay. So now we discuss first one, that is a logical shift. Okay, that is a logical shift micro operation. We can tell as logical shift micro operation. Okay. So I have already told, if we go through logical shift micro operation, then what happens? We will also take, that is a two ways. One is left to right or right to left. Okay. That means two cases we will consider: logical left shift. We can tell logical left shift. Okay. Now we will consider logical left shift. Very example we will see, that is different example we will consider. That means logical left shift means that is shift towards, okay, shift towards left, right to left. Logical shift left shift means right to left. Okay, that means right to left. Take an example, then we can understand how it is designed. Let 4 bits data or information, 4 bits information. Let us consider that is 0, 0, 1, 1. Let us consider this 4-bit data we can consider. Okay. Now whenever go through, that is logical left shift means right to left. It means we can write also right to left, means data transfer from right to left. Okay. So now very simple way we can also consider how it will be shift each individual bits. Okay. Right to left we have to shift. Now we see, whenever go through this one, first of all we see we define two that is two side or side bits consider as a least significant bit. Here we can tell as a least significant bit. Okay, LSB we can tell as a, this is a LSB, and here we can tell as a MSB. Remember, most significant bit and least significant bit we can tell. Very simple way we can that is also defined in this way. That is a least significant bits. Which one? Right hand side. If we go through left hand side, we always consider MSB is most significant bit. Okay, most significant bit. This is that is a two side bit we will consider in this way. Now see, we have to shift our data from right to left to call as a logical left shift. Okay. Now we see how we will shift. Shift means a very simple way. I will tell you, then we can understand. Here right to left, that means starting from LSB just one bit shift to the, that is a shift operation of a shift serial number. Here you see it transfer to here one position, just a transfer 1 to here, we can write here just a transfer 1 to here 1, here 1 to 1. Okay. Here what happens, if 3 bit transfer here and occupy the position, then what happens, you see this will be discarded because that is no space, because it has 4 cell. We occupy this cell through corresponding the bits. There is no space after this 4. Okay, then this should be discarded. Okay, discarded or rejected, as you like, that we can also tell. Okay, but in the right hand side, then what happens? The no data here, you see no data. Then what happens? But since it is filled up by 4 bit, we have to fill out by, that is 0. Okay, we have to fill out by 0, means add 0 in LSB. Okay, add 0 in LSB. Now see, it is very easy way if we go through this logical left shift. Very simple way. Once again I will tell you. If we go through 4 bits, we have to always consider 4 bits. If we 8 bits, 16 bits, it doesn't matter. Whatever the bits of information, we can take it, doesn't matter. But think that whenever you go through this kind of bits, then how it will shift from left to right or right to left. Since we consider this logical left shift, so we start from LSB occupy the second position of the next serial bits. Next one, next bit, next, whatever the next. Okay. So right and left hand side or MSB bit, what happens? It will be discarded since there is no position to occupy by this bit. This is the one concept. Another concept is, since it is shifted, so this particular space will be vacant. So it will be that is filled up by 0. Okay. Now test it how that is shifted. Whenever I shift it, then what is the result? By using the, that is a decimal number. Now see, very simple here. Suppose we go through this one. What is the number? If we go through this particular number, what is the value of this? Here is 1, here is 2. 2 plus 1, that is 3. Okay. Now check it here. If we go through this one, then what is the value? Okay. What is the value? Oh, sorry. Here is actually 0, not 0, it is 0 actually. It is 0 because this is 0. 1, 1, this is 0. Okay. So, what is the value? This particular value will be calculated. Now, here is 2, here is 4. 4 plus 2, that is 6. Okay. That is 6. That means whenever you apply 6 means it is double. Okay. 3 into 2. That means whenever your data transfer from the right to left or using this logical left shift, then it will multiply by 2. I told already. It is a multiply by 2 whenever data transfer from, that is a right to left. I have already told in this way. You see, very simple way I already mentioned. If it transfers from that is left to right, sorry, if it transfer from right to left, then it gains multiplied by 2. If that is reverse, left to right, it is divided by 2. But here in this case what happens? Left shift means move from right to left. Then it is multiplied by 2 because I have already mentioned it is multiplied by 2. So it is multiplied by 2. Okay. Another example we can take, then maybe you will confirm. Again we see same thing. Again you see, if we go through again, that is a left shift also apply. Now continue that. Then how it is how you get this kind of a result, you see. Now again this is the LSB, this is the MSB. LS is 0, MSB also 0. Now see, this shift to here, okay, that is 0. This shift to here, that is 1. This shift to here, that is 1. But this will be discarded. Okay, this will be discarded or rejected. Again what happens? I told the first one since not available, or we can add 0 since it is empty space. It will be 0. Now calculate the value. What is the value? Here will be, here is 2, here is 4, here is 8. 8 plus 4, that is 12. You see, it is 12. Whenever we shift from right to left, then it will multiply by 2 to 2. Okay, I told that already, that is a multiply by 2. So automatically you see 6 into 2, it is 12. Again we will go through that. Again we will see that what is the, how many times it will multiply. Okay, this is the basic concept whenever go through this particular data. Okay, go through from right to left. So we can call this a logical shift, left shift. Similarly, we can go through another way, that is a logical that is a right shift. We can tell second part also there, logical right shift, logical right shift. Okay, very simple way. Let us consider right shift means from left to right. If you left to right, then obviously lose some data. Okay, because right hand side some data will shifted, so lose some data. It is that is gain some data. So very simple way I will tell you. Then we will consider that is a 4 bits. Similarly, here will be MSB, here will be LSB. Okay, MSB, LSB. So now see, very simple way. Let us consider 1 0 1 0. For example, 1 0 1 0. Now you shift this data to another form. You see what is the result. So now what happens? We have to shift it towards right, since a right shift. That means left to right. Same cases also we apply. Very simple way. Here you see, first one not fill up, so it is shift to 1, second position. Here shift to, that is 0. Here shift to, that is 1. Okay, but this will be discarded. This will be discarded or rejected. Okay, but it is not filled up by this one. Then what happens? Same thing, we just fill up by 0. Okay, it just fill out by 0. So very simple. Now check it. How, what is the result? Now see, here if you calculate this decimal number of this number, how much? That is here is 2, here is 0, here 2, 4, 8. 8 plus 2, the decimal number is 10. Okay. So now if you calculate, here you see, here is 1, here is 2, 4. 4 plus 1, that is 5. That means initially you consider 10 or you take 10. Whenever shift towards the right, so it is divided by 2, that is 5. I already told. Okay, if the shift operation used from, that is left to right. If left to right, it loses some data divided by 2. So it lost some data divided by 2. Okay, very simple way. It is very, that is a simple way. We can transfer, we can shift our data from left to right or right to left. Okay, very simple way. Similarly, different ways we can consider. Okay, there is no problem. Either we take, that is 8 bit 4-bit, 16-bit or any data, doesn't matter, as you like. You can also take different bits of data, then we can apply how apply the either logical right shift or logical left shift. Based on that, data will be multiplied by 2 or divided by 2. That is, based on that, data will be that kind of data or that kind of output we can get it. Okay. So this is the logical shift micro operation. Okay. So next lectures I will show you, that is another part, that is a arithmetic part. Okay. That is a arithmetic shift operation, how it will operate. Okay. Thank you very much. Thanks to all to watch my videos. I will explain this very understandable view or understandable concept and a very easy way. That is explain this part. So thank you very much. Please subscribe my channel and proceed very long way. Many students, many that is teachers also can get more benefit if they regularly use my channel and see my videos. Okay. Thanks to all. Okay. And please comments on these videos if you want, and that is like it. Okay. Thanks to all. Thanks.